Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope you guys are doing great, having the good time. Well people, first of all, you can let me know in the chat box if I'm audible and visible to everyone. Hello Ishpreet, hello Gautam, hi Sudeep, hi Archana, hello Vandana, hello Diksha, hello Aisha, hello Fazan, hi Varshni, hello Ashwarya, welcome back people, hello Furkan, hello Jaswant, hello Faisal. Faisal, the top-notch 100 questions will be there on Saturday, yeah? Perfect. So just let me know, give me some confirmation in the chat box if I'm audible and visible to you guys, right? Give me some confirmation people, fast, give me some green signal from the chat box. Welcome back everyone, welcome back. Welcome back people. Okay, wonderful. So as you all must be doing tonight, it's going to be the session, right, which is based on the quantum mechanical model. We'll be talking about something called as Schrodinger's wave equation, correct? We'll be discussing something about the nodes, right? All those things we'll be covering in the tonight's session, correct? Yes. So people, before starting the session, the ones who are new to the channel, let me introduce myself. Well, my name is Wassim Bhatt and I'm your chemistry master teacher writer on this NEET Elite channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yes, Harshal, Wassim Sir is back. Yes. Which is the next chapter? I'll let you know about the next chapter. I'll see which chapter to take, right? Let's talk about that afterwards once the session ends, yeah? Right? Perfect people. So you can let me know in the chat box first of all if you guys are super duper excited about the session, right? Let me know in the chat box if you people are super duper excited about the session. Let me see the josh of the session first, right? Yes. Let me see the josh of the session first, then I'll be starting the session, right? We are meeting after so long, yeah? Right? Perfect people, perfect. Okay, one important thing which I would like to share with you before starting the session. Whatever I'll be writing on the screen, I want you guys to take a note of every single thing which I'll be mentioning on the screen, right? The session is going to be very, very informative today. So I want all of you to note down every single thing what I'll be mentioning on the screen, right? Okay, perfect. Should we get going? Yeah? Perfect people. Just a second. Right. Okay, so let's get started with something called as quantum mechanical model, right? Quantum mechanical model. Okay. The first point which we are going to talk about this quantum mechanical model is, let me tell you, it's based on this quantum mechanical model, it's based on de Broglie's concept, and Heisenberg's uncertainty principle. Right? Both the concepts we have discussed in detail in the earlier sessions, if you remember. We have discussed about the Heisenberg's uncertainty principle. We have discussed about the de Broglie's concept as well, right? Okay. Now people, the first thing. We know, as per your de Broglie's concept is concerned, whenever I'll be having a particle carrying certain mass m, for example, moving with velocity v, whenever I'll be having any particle carrying some mass, carrying some velocity, right? This particle will be having a wave associated with it, right? It'll be having a wave associated with it. Correct? Whenever the particle having certain mass moving with certain velocity v, right? The particle carries a wave with it. There will be a wave associated with the particle moving with velocity v having mass m, right? In the similar way, if you remember, let's assume this is the nucleus, right? This is the electron moving in the shell, for example, right? Okay. See, when the electron moves in the shell, electron carrying some mass, right? Electron has got certain velocity. That means with this electron, there will be one wave associated with it, right? There will be a wave associated with this electron as well, correct? Because as per your de Broglie's concept, whenever a particle having certain mass moving with velocity v, right, it will be having a wave associated with it. Similarly, I have got the electron moving around the nucleus, right? The electron has got definitely some mass, it has got some velocity, so there will be a wave associated with this electron as well. This is something you all must be knowing, right? This is something which we have discussed in detail, yeah? Now people, understand what I'm going to tell you now. See, let's say this is your x-axis, let's assume this is the y-axis, right? Okay, this is my coordinate system. This is, for example, x-axis, and this is the y-axis. Let's say I have got the particle following this path. The particle starting from the origin, it's following this path, right? It's following this path. First of all, can I say it's a straight line passing through origin, right? What is the equation for the straight line passing through origin? The equation is y is equal to mx. We know it, correct? Any particle which will be following this path, should follow this equation as well, right? Because this is the equation which governs this path, right? Yes, this is something which we know, correct? See guys, simple. I took a coordinate system, this is y-axis, this is your x-axis, right? Let's say I've got a particle which is following this path, straight line path, right? First of all, what is the equation for this straight line? For this straight line, it's y is equal to mx, right? Any particle which moves along this path will follow this equation, y is equal to mx. We know it, correct? Similarly, people, as I told you, when the electron moves around the nucleus, electron carries some mass, electron carries some velocity, right? When the electron moves around the nucleus, there will be a wave associated with that particle, right? There will be a wave associated with this electron, correct? This is the wave associated with the electron, correct? And let me tell you, the equation which governs this wave, that is written like this. Psi is equal to A sine 2 pi x divided by lambda, right? The equation which governs the wave which is associated with the electron, that is written like this. Psi is equal to A sine 2 pi x divided by lambda, right? What is this psi called over here? This psi is called as the wave function of the electron, right? It's called as wave function. Just a second. It's called as wave function, correct? What is this A over here? A is the amplitude of the wave. Amplitude of the wave. This is A over here, right? Okay, first of all, it is a standing wave. It is a standing wave which is basically associated with the electron when it moves around the nucleus, correct? This is something which you all must know, correct? What is the psi called? Psi is called as the wave function, and this A is the amplitude of the wave, right? Let me write it over here. A is the amplitude of the wave. Understand all the things what I'll be mentioning on the screen. Okay. Now the first thing which I'll be doing over here, this is the equation which characterizes the standing wave which is associated with the electron while moving around the nucleus, right? Now people, if I'll differentiate this equation, with respect to x, right? If I'll partially differentiate this equation with respect to x, what is something which I'll be getting? I'll get dou of psi divided by dou x. It's going to be equal to A is a constant, right? Sine 2 pi x divided by lambda. Its differentiation is going to be cos of 2 pi x divided by lambda multiplied by 2 pi divided by lambda, right? Differentiation of this whole function, then the differentiation of this part, right? Then the differentiation of this part, which is 2 pi divided by lambda, correct? Now at the same time, what I'll be doing, I'll be differentiating this equation again. It becomes dou square psi upon dou square x, dou square psi upon dou x square, right? It's going to be equal to A, I'm writing as such because A is a constant. What is the differentiation of cos of something? Differentiation of cos of something is minus times sine of the angle, which is 2 pi x divided by lambda, and already there was 2 pi divided by lambda. Now you'll do the differentiation of this part as well. It becomes 2 pi divided by lambda ka square, right? What I simply did, I again differentiated this equation. I differentiated this equation with respect to x again. I partially differentiated this equation with respect to x, right? Now we will see what I'll be getting over here. I'll be getting something like this. Dou square psi upon dou x square is equal. Understand? It's going to be minus times minus times a, correct? It's going to be sine of 2 pi x divided by lambda, and this is going to be 4 pi square divided by lambda square, correct? 4 pi square divided by lambda square, yeah? Now, let me erase this part. I'm sure this is something which you would have already written, correct? Let me erase this part over here. Now, we will understand few important things. And remember this, okay? See, I'm going to write something like this. Dou square psi upon dou x square is equal. See, a sine 2 pi x divided by lambda. This a sine 2 pi x divided by lambda. This is something which we call as psi, correct? So I'll be writing minus times. I'm writing minus times psi. And with this, you have got 4 pi square divided by lambda square as well. I'm going to write 4 pi square divided by lambda square, correct? People, if you remember the de Broglie's hypothesis, we know lambda is equal to h upon p. So can I say lambda square is equal to h square upon p square, right? I'm squaring on everywhere, right? So lambda square is simply going to be equal to h square upon p square, yeah? Now understand. Can I write this lambda square like this? Lambda square is equal to h square divided by p square. What is p square all about? What is p square? P square is simply going to be equal to 2m multiplied by kinetic energy of the electron, correct? Instead of p square, I'm writing 2m multiplied by kinetic energy of the electron, right? Because you know, you all must be familiar with the fact kinetic energy of the electron is equal to half of mv square, right? If I'll multiply with mass and divide with mass, there'll be no issue at all. I multiplied the equation with mass and at the same time I divided the equation with mass as well, correct? So kinetic energy becomes equal to m square v square is something which I call as p square divided by 2m. So instead of this p square, I can write 2m multiplied by kinetic energy. Same is the thing which I wrote over here. Instead of p square, I'm writing 2m multiplied by kinetic energy, right? I'm sure it's clear to you. Now what I'll be doing, I'll be putting the value of lambda square into this equation. I'll be getting something like this. This is dou square psi upon dou x square. This is equal to minus times psi, correct? It's going to be 4 pi square divided by, instead of lambda square, what do I need to write? Instead of lambda square, I'll be writing h square divided by this term, and that term goes into the numerator, which is 2m multiplied by kinetic energy, correct? Yes, this is something which I wrote over here, correct? So people, this is something which I'll be getting at the end. Dou square psi upon dou x square is equal. It's going to be minus times psi, correct? It's going to be 8 pi square m multiplied by kinetic energy. Kinetic energy of the electron can be written as total energy of the electron minus potential energy, right? Yes, kinetic energy of the electron is written as total energy of the electron minus potential energy of the electron, right? Divided by what? Divided by h square over here, correct? Yes. Now people understand. I'm sure you would have noted down every single thing till here. So what I'll be getting something like this. See, just I'll take this minus sign on the left hand side. I'll be getting dou square psi upon dou x square plus 8 pi square m multiplied by e minus v divided by h square multiplied by psi is equal to 0. If I'll ask you, is this the complete Schrodinger's wave equation? This is not the complete Schrodinger's wave equation. Why is that? Because we have got only x coordinate over here, right? I'll be adjusting y coordinate as well as z coordinate in this equation. Then the equation which I'll be getting finally, that's something which I call a Schrodinger's time independent wave equation, right? So this is my equation. This is my final equation. Dou square psi upon dou x square plus dou square psi upon dou y square plus dou square psi upon dou z square plus 8 pi square multiplied by m into e y minus v multiplied by psi divided by h square is equal to 0, right? This is something which you guys are going to remember, right? If you're not able to remember the derivation, no issue at all. You just need to remember this equation. This is something which I call as Schrodinger's wave equation, right? And this is what we call as basically Schrodinger's time independent wave equation. Schrodinger's time independent wave equation, correct? Got it? Noted down every single thing till here, right? No, you do not have to remember this derivation. So it is just I wanted to show it to you, so I showed, right? Yes? It's not asked in your examination or something, right? You just need to remember this result at the end. That's all, right? Yes? Perfect, people? Perfect, perfect. Is everything clear till here? Yes, Ariba, it is completely possible, right? It is possible. Perfect till here. Have you noted down every single thing? Have you noted down every single thing? Yeah? Correct? Okay, now people understand. Now people understand. We have noted down a term called as psi. We have noted down a term called as psi. First of all, let me write the equation again. It is dou square psi upon dou x square plus dou square psi upon dou y square plus dou square psi upon dou z square plus 8 pi square m multiplied by e minus v divided by h square is multiplied by psi is equal to 0, right? Okay, now there is a term called as psi over here. There is a term introduced over here, that's psi. What is psi all about? I told you. Psi is basically the wave function of the electron. Psi is basically the wave function of the electron. Remember one thing. If you remember your Heisenberg's uncertainty principle, it's impossible to determine the exact position and the momentum of the electron, for example, simultaneously with 100% accuracy, right? So that is why probabilities was introduced. The term probability was introduced due to Heisenberg's uncertainty principle, right? Okay. We always talk in terms of probability of finding the electron around the nucleus, right? We always talk in terms of probability of finding the electron around the nucleus, correct? Okay. Due to your Heisenberg's uncertainty principle, your Bohr's model was completely failed. Yes, we have discussed all that in detail if you remember, correct? Now people, remember probability of finding the electron, probability of finding the electron at a point around the nucleus, is directly proportional to the value of psi basically. More the value of psi, more is the value of this psi, which is the wave function of the electron, more is going to be the probability of finding the electron at a point around the nucleus. Remember this thing as well, right? Now there is something interesting which you need to remember, which you need to take a note of. What is that thing? Understand properly what I'm going to tell you now, okay? See guys, understand properly. For example, I'm making the coordinate system over here. Cartesian coordinates, right? See, this is for example your x-axis, right? Let's assume this is your y-axis, right? Let's assume this is your z-axis, correct? This is the z-axis, yeah? Let's assume over here at the center, this is the nucleus of the atom. This is the nucleus of the atom, right here at the origin. At the origin, you have got the nucleus of the atom. Let's say the electron is somewhere here. Correct? Basically, it's not present in XY plane. See, this is basically your x-axis, this is y-axis, this will be your z-axis, right? And for example, the electron is present somewhere here. Not on the board, just above the board somewhere here, right? In the space, right? In the space, correct? Now people understand. Let's assume the coordinates of this electron is x, y, and z. These are the coordinates of this electron, which is situated over here, okay? It's not basically present on xy plane. It is present in the space somewhere here, just above the plane right here somewhere, right? Okay, exactly, it's a 3D plane, yeah? Now you'll understand. Let me join these 2 points, okay? Let's say the distance between the nucleus and the electron is represented by r radius vector. Okay, this is r over here, correct? Yes. Now people understand properly. Let's assume this r over here, this radius vector, it's making the angle theta with this x-axis. With this axis, right? It's making the angle theta with it, okay? It's making the angle theta. Now first of all, I'll be resolving this radius vector into its 2 components. See, this r is making angle theta with this y-axis, right? So towards this y-axis, there will be what? There will be r cos theta. This is the component of your radius vector along y-axis, yes? Okay. Now people, over here somewhere, there will be one more component of this r. It's going to be r sine theta. Right? Now at the same time, understand one more thing. Let's say this r sine theta, it's making some angle alpha with this x-axis over here. Sorry, not alpha, let's say it's phi. Let's say this r sine theta, it's making angle phi with this x-axis over here. So if I'll ask you, first of all, let me tell you this r sine theta, it is present on xz plane. This r sine theta, it's present on xz plane, right? Let me modify it like this. This is basically your xz plane in which your this r sine theta vector is present, right? Okay. Now people understand properly. See, this is r sine theta basically. This is r sine theta, correct? This is the angle phi with the x-axis. So in this way, can you let me know what is going to be the component of r sine theta along x-axis? You will say it's going to be r sine theta multiplied by cos of phi, correct? This is the component, r sine theta cos of phi is the component of this r sine theta towards x-axis. Similarly, if I'll ask you, what is the component of this r sine theta towards the z-axis? What it's going to be? It's going to be r sine theta, or let me write it somewhere here like this, just a second. See, the component of r sine theta towards the z, it's going to be r sine theta multiplied by sine of phi, yeah? Okay. Now we will have a look. This is basically your y coordinate. This is basically your z coordinate. This is basically your x coordinate, right? Basically, these were the Cartesian coordinates x, y, and z, right? Now I convert this x, y, and z into the polar coordinates. I converted this x, y, and z into the polar coordinates over here, yeah? Okay, what is x all about? X is simply r sine theta cos phi, y is simply r cos theta, and z is r sine theta sine of phi. Okay. Now people see, this is the Schrodinger's time independent wave equation, right? Have I used any polar coordinates in this equation right now? I have not used any polar coordinates into this equation right now. Yes? Right? Yes, people? It's very simple. See, I have not used any polar coordinates into this equation right now. I have used the coordinates x, y, and z. Now what I'll be doing, if I'll put the value of x, y, and z, see, I got the value of x, I got the value of y, I got the value of z, right? If I'll put all these values of x, y, and z into this equation, I'll be getting Schrodinger's equation in the polar coordinate form, right? I'll be getting Schrodinger's equation into what? In polar coordinate form. Yes, in the polar coordinate form, right? See, if I'll put the value of x, y, and z, since I got the value of x, I got the value of y, I got the value of z, if I put the value of x, y, and z into this equation, I'll be getting the Schrodinger's wave equation in the polar coordinate form, point number 1. Yes, right? I'll be getting the Schrodinger's wave equation in the polar coordinate form. Now the Schrodinger's wave equation which I'll be getting in the polar coordinate form, what I'll be doing is, I'll be solving this equation. I'll be solving the Schrodinger's polar coordinate form equation, right? After solving the Schrodinger's wave equation, which is in the polar coordinate form, I'll be getting the value of psi. I'll be getting the values of psi in the polar coordinate forms as well, right? After solving the Schrodinger's wave equation, what do I get? After solving this Schrodinger's wave equation in the polar coordinate form, I'll be getting the values of psi. I'll be getting the values of wave function in the polar coordinate form. I'm mentioning it over here. This r, this is theta, this is phi, right? And every value of psi which you get, there will be two components in every value of psi. See, you'll be getting some value of psi over here. In every value of psi, there'll be two components. Right? There'll be two components. One is called as radial component, one is called as angular component, right? Okay, so every value of psi will be containing two functions. One is called as radial function, one is called as angular function. Yes? Radial function is represented by r of r, right? Multiplied by what? Multiplied by, this is going to be theta of theta, correct? Similarly, I'm writing it over here, multiplied by, this is going to be phi of phi, correct? Over here, this is something which I call as radial function. I'll be letting you know, I'll be making you understanding this in some time. Just remember these things first of all. This is something which we call as radial function. Yes, and this whole is something which we call as angular function. See, first of all, see what I did basically. I got the Schrodinger's wave equation, right? In the Schrodinger's wave equation, when I replace x with r sine theta cos phi, when I replace y with r cos phi, when I replace z with something which I derived a few minutes back, which was, I guess, r sine of theta sine of phi, okay? I'll be getting the Schrodinger's equation in the polar coordinate form, yes? Right? And when I'll be solving that Schrodinger's wave equation in the polar coordinate form, I'll be getting the values of y. Like we have quadratic equation. For example, we solve the quadratic equation. What do we get? We get the roots. Similarly, the Schrodinger's wave equation, which will be there in the polar coordinate form, if I'll be solving that, I'll be getting roots of it. I'll be getting roots of it in terms of psi, correct? And every psi value will be containing two parts. One is called as the radial function, one is called as angular function. One is called as a radial function, one is called as angular function, okay? Now people, what kind of idea this radial function gives me about the electron? What kind of idea this angular function gives me about the electron? That's something which we need to understand. Let me know first of all, is everything clear till here? Let me know fast. Sanjay, it's starting from next week. Yes? Perfect till here? Have you noted down every single thing till here? Yeah? Okay. Sanjay, next week on Monday it's starting, mostly. All right, now people understand few more important things. Just give me a second. Let me erase this part. I'm sure it's clear till here, right? Now what I'll be doing over here is, see, I'll be squaring this equation. If I'll square this equation throughout, it becomes psi square. This is r, this is theta, this is phi, right? It's equal to r square r, correct? Multiplied by theta square theta, multiplied by phi square phi, correct? Now understand, what do we call this r square as? This is called as radial probability. This is called as radial probability density. I remember these terminologies. And this whole part is called as angular probability density. Okay. Now what kind of idea this radial probability density gives me, what kind of idea this angular probability density gives me, right? Okay, let's understand this a bit more in detail. See guys, see, for example, I'm the nucleus, right? I'm the nucleus. I need to find the probability of electron at a point around me. I'm the nucleus. I need to find the probability of electron around me, around nucleus, right? At certain distance r, right? Let's say this is r distance from me. I'm the nucleus, right? From here to here, it's r distance. From here to here, it's r distance. I need to find the probability of finding the electron. I need to get the probability of finding the electron at this point, at the distance r from the nucleus, right? Okay. There'll be infinite number of parts. There'll be infinite number of points like this, which will be equidistant from me, right? Okay. Which will be at a distance of r. Let me make you understand it like this. See guys, understand properly what I'm going to say. Understand, this is confusing a bit, okay? Understand properly. See, for example, I'm the nucleus, right? I'm the nucleus, correct? At this point is at a distance r from me. This point is at a distance r from the nucleus. I need to find the probability of finding the electron. I need to get the probability of finding the electron at this point, which is r distance from the nucleus, correct? Yes, that is something which this part will take into account, right? This part, this r square r, it's going to give me the idea about the probability. It's going to give me the idea about the probability of finding the electron at a point which is, for example, which is r distance apart, which is r distance from the nucleus, right? Okay, right? So once again, I'm telling you the same thing. Let's assume I'm the nucleus, right? I'm fixing a point over here. At this point, which is at a distance r from me, which is a distance r from the nucleus, I need to get the probability density of the electron at this point. Yes, I need to get the probability of electron at this point, right? Which is r distance apart from the nucleus, correct? How will I be getting it? This term, this r square r, which is what I call as the radial probability density, it's always going to give me the probability of finding the electron at a point which is our distance apart from the nucleus, right? Yes. Now people understand what kind of data, what kind of information this term gives me, or what kind of information this whole term gives me. What kind of information this whole term gives me. See, this is a point which is r distance apart, right? This is a point which is r distance apart, okay? At this point, I need to get the probability of electron. I need to get the probability of, I need to see the probability of finding the electron at this point, which is r distance apart, right? Your radial probability density is going to give me the probability of finding the electron at this point from the nucleus, correct? Similarly, if I drag my hand in this way, that means I'm changing the angle, right? I just changed the angle. For example, I just changed theta. I just changed theta, right? Okay, this point over here, it's again r distance apart from nucleus. I'm changing angle bit more, right? I'm changing the angle bit more, okay? So basically at this point is also r distance apart from the nucleus, correct? I'm taking the hand up over here. This point is again r distance apart from the nucleus, right? Okay, so basically on changing the angles, what I'm getting? I'm getting the probability of finding the electron at every point on the surface which is basically r distance apart from the nucleus. I'm sure it's clear to everyone, yeah? People, are you getting it what I'm saying? Are you getting it what I'm saying? Are you getting it? Sanjay, you can take it tomorrow. You can take it tomorrow. People, did you get what I said? Did you get what I said? Yeah? See, I'm going to tell you the significance of this whole term. That means this psi square. This psi square gives us the probability of finding the electron right, at a point on the surface around the nucleus, right, which is at a distance r from it, from the nucleus, right? I hope you got it. Let me know fast in the chat box. Is it clear, people? Is it clear? Let me know fast. Let me know fast in the chat box if it is clear to you. Yeah? Okay. So basically, this psi square, it gives the probability of finding the electron at a point, right? Okay. Basically, this psi square, it has got two components. Again, I'm telling you, one is your radial probability density, one is your angular probability density, right? Okay. This part, it gives me the idea about the probability of finding the electron at a point which is r distance from the nucleus, right? Now, if I change the angles in all the ways, I'll be getting a surface around me. Right? Which is r distance apart. And on that surface, there'll be infinite points, correct? Okay. So basically this whole term is giving me the probability of finding the electron at a point on the surface which is r distance apart from the nucleus, right? Yes, I'm sure it's clear to everyone. Okay. Let's move on. Let's talk about something called as nodes. Correct? Yes, Hari, after September 12, I'll be taking regular sessions for you. Yes. After September 12, I'll be taking regular sessions for you, right? Let the NEET 2021 go off, then I'll be taking regular sessions for you only. Okay? Now, people, all of you must be knowing mod of psi square. This is something which I've already told you. Mod of psi square. What does it give me? It gives me the probability of finding the electron. I told you, probability of finding the electron at a point. Okay? Let me not write it. Let me write something called as node. What is a node? This is something which I've told you in the last session as well. It is the region around the nucleus at which the probability of finding the electron is minimum, is 0, right? Okay? The region around the nucleus at which the probability of finding the electron is minimum, or you can say the probability of finding the electron is 0. That's something which we call as node, correct? Okay? Point number 1. Point number 2, people. See, if I'll be writing something like this, for example, I'm writing psi 410. What it denotes? what it denotes. What it denotes. I wrote something as psi 410. What it denotes exactly. See guys. See. Oh, one thing I forgot. See. In your psi function, in your psi function, what was that psi? That psi was basically, that was psi, this is r, this was theta, this was phi. It had two parts. One was your radial function multiplied by one was your angular function, right? Radial function, it depends on the value of n and l, and your angular function, it depends on the value of l and m. Remember this thing as well, right? Radial function, it depends on the value of n and l, and your angular function, it depends on the value of l and m, correct? Yes? Now people, I'm representing something like this. Psi 410. See guys, what is psi? Psi is the wave function. See how wave function is represented generally. First psi, then n, then l, then m, right? This is the general representation of your orbital through wave function. Okay? See, this simply means the value of n is 4, right? This simply means the value of l is 1. This simply means the value of m is 0, right? So psi 410, which orbital it represents? It represents 4p orbital. It represents 4p orbital, right? Okay. For example, I've got something like this, psi 320. Okay. Can you let me know which orbital it represents? 3. It's going to be 3. L is equal to 2 for d, right? So it represents your 3d orbital. Yes. For example, I'm writing something as psi 200. Psi 200. Can you let me know first of all which orbital it represents? It represents 2s orbital, right? So remember this notation as well. I'm sure it's clear to everyone, right? Perfect. Exactly, guys. Now comes the point. That's what we call as node. That's what we call as node, correct? Node is the region around the nucleus where the probability of finding the electron is minimum or probability of finding the electron is 0, right? That's something which we call as node. Well, people, there is a formula to calculate total number of nodes, and the formula is n minus 1. By this formula, you can calculate the total number of nodes. Yes. And these nodes are basically of two types. One is called as spherical. One is called as spherical or radial node. One is called as the angular node. One is called as the angular node. Correct? Let me tell you, this spherical node is calculated by the formula n minus l minus 1, right? And the angular nodes, these are calculated by the formula of L, where L is the azimuthal quantum number. I want you guys to remember this thing as well, okay? Yes, Sanjay, you can get enrolled into my batch, yes. Okay, so people, what I'm telling you, your nodes are of two types, spherical nodes, angular nodes. This is the formula by means of which we can calculate spherical nodes. This is the formula by means of which we can calculate angular nodes, right? Yes? Yes, people? Now, for example, let's say I have got 1s orbital. I have got 1s orbital. If I'll ask you how many total number of nodes are there in 1s? Total number of nodes in 1s, n minus 1. N value is 1, 1 minus 1 is 0. So there is no node in case of 1s. There is no node in case of 1s, right? Yes, there is no region in 1s where probability of finding the electron is 0, correct? If I talk about 2s, how many total number of nodes are there? N minus 1. N value is 2, 2 minus 1 comes out be 1. There is only one node in 2s. Now, let's identify, is this node the spherical node or angular node? Is this node the spherical node or angular node? Angular node is calculated by the value of L, and L value for S is 0. So that means in case of 2s, there is no angular node. So this node is basically the spherical or radial node in 2s, right? Similarly, I'm talking about 3s. How many total nodes will be there? 3 minus 1, 2. Now I need to see, are both these nodes angular nodes? Are both these nodes spherical nodes? Is one among it angular, one among it radial, right? How do I check that? There's a formula for it. I told you a few minutes back. Yes? See guys, if I'll ask you, what is the value of L for S? 0. So there is no angular node. So both these nodes are basically your radial nodes, correct? Both these nodes are radial nodes. Similarly, if I'll be having something as 3p, how many total nodes? 3 minus 1, 2. So there are total 2 nodes. Now among these 2 nodes, I need to see how many of them are spherical, how many of them are angular, right? For p, the value of L is 1. So there is one angular node. Out of 2 nodes, one is angular. That means one will be spherical, right? So one spherical node, one angular node, right? Yes. Similarly, I've got something as 3D. How many total nodes it has? 3 minus 1, 2. 3 minus 1, 2, yeah? 3 minus 1, 2. Now I need to see, out of these 2 nodes, how many are spherical, how many are angular, right? In case of D, what is the value of L? The value of L is 2. So both the nodes are angular. That means there will be no spherical node because total nodes are 2 and both these nodes are basically your angular nodes, right? Yes? I'm sure it's clear to everyone. Right, people? Right? Now comes the point. Now what I'm going to do is I'm going to make some plots. I'm going to make some curves. First curves I'm going to make between psi versus r. Psi versus r curves, right? I'm going to plot psi versus r curves. Okay? I'm going to plot psi versus r curves. Understand properly what I'm going to say. Let's say I'm starting with 1s. And remember, first of all, I'll be starting with your s orbitals. And this is something which I want you guys to remember. Psi versus r curves for s orbitals, they do not start from the origin. Okay, let me show it to you first of all, then I'll be writing the statement. I'm keeping some space over here to write the statement, okay? For example, I'm talking about 1s orbital. I have got 1s orbital, right? In case of 1s orbital, if I'll ask you, how many total nodes are there? N minus 1. 1 minus 1, that is 0. That means there is no node in case of 1s. There is no node in case of 1s, right? There is no node in case of 1s, okay? Right? And remember, in case of your s orbitals, as you move closer to the nucleus, the electron density increases. In case of s orbitals, as you move closer to the nucleus, the electron density increases. Remember this. As you go far from the nucleus, in case of s orbitals, the electron density decreases, right? See, if I want to plot a curve between psi versus r, for 1s, okay? First of all, if I'll select a point over here, can I say at this point psi value is 0? If psi r is 0, that means it's a radial node. It is the point at which the probability of finding the electron will be 0 in the atom, right? Every point on r represents psi r as 0. And if psi r is 0, let me tell you, if psi r is 0, what does that mean? That represents the radial node. Okay? So, the curve which I'm going to draw, if at any point the curve touches this, the curve cuts this r-axis. That's going to represent a node. Right? Let's understand. See guys, if I talk about 1s, in case of 1s, there is no node. So your curve, first of all, will be starting from here, and it's not going to touch this r-axis. Over here, right? And if I need to represent it exactly, this is the nucleus. This is the electron density. And people, you won't find a single region around the nucleus in case of 1s where the probability of finding the electron is 0. That means there is no node over here at all, right? There is no node present in case of 1s, correct? Similarly, if you talk about 2s, how many total nodes are there? N minus 1, 2 minus 1, that's 1. There is one node. Is this one node radial or angular? We have seen a few minutes back. This is basically your radial node. Right? Okay. People, this point says r is equal to 0. That means I'm approaching the nucleus. In case of s orbitals, as we move closer to the nucleus, the electron density increases, right? Similarly, as I move in this way, what will happen to electron density? It will decrease, right? Correct? Yes? Right? Now we will understand. If you want to make a curve for 2s between psi r versus r. So first of all, how many radial nodes are there? There is one radial node, right? See, this point represents what? It represents r is equal to 0. That means I'm closest to the nucleus. In case of s orbitals, the electron density is maximum closest to the nucleus, right? And then it decreases, How many nodes are there? There is one node. Which node is it? It's a radial node. So that one node will be represented like this. This is a node, correct? This is a node. The curve will be like this, then it will come up, then it's not going to touch the r-axis back, right? This point says simply your psi r is 0, and the point which says psi r is 0, that's something which I call as the node. And which node it is? It is the radial node. Correct? It is the radial node. Yes? So this was the curve which is valid for 2s. Similarly, if you want to make it for 3s, how many total nodes are there? There are 2 total nodes, right? And both these nodes are basically your radial nodes. Okay, so there will be, the curve will be touching this Rx is at 2 points. The curve will be touching this Rx is at 2 points, right? Yes. So let me show it to you exactly. See, this is for example psi r versus r, right? The curve will be somewhere coming from here. This is one node, then it will be going up. This is another node. Since it has got only 2 nodes, now it's not going to touch it, right? So this point and this point, these 2 points represent the radial nodes, right? Right, people? Right? Clear till here? Okay. Similarly, if you want to plot a curve for 4s, you can do that, right? But before plotting a curve for 4s, let me tell you one important thing now. See, I made a curve for 2s, right? In case of 2s, there is one radial node, right? How do we picturize this? How do we picturize this 2s? How do we picturize this 2s? In case of 2s, there is one region around the nucleus where the probability of finding the electron will be 0, right? See guys, if I'll have to plot the 2s, okay, this is the nucleus, this is the electron density, for example, this is the electron density, right? Now after this, there'll be one region where the electron density will be 0, and after that electron density will be again there, right? Like this. So you can see there is one spherical region in the middle. There is one spherical region in the middle where the probability of finding the electron is 0, and this is something which I call as radial node over here, or you call it as the spherical node over here. So which orbital this is? This is your 2s orbital. This is your 2s orbital, correct? Similarly, if you want to plot for 3s, if you want to see how this 3s looks like, if you want to see exactly how this 3s looks like, how it looks like in case of 3s, there are 2 radial nodes basically, right? So there'll be 2 spherical regions like this where the probability of finding the electron will be 0, right? And how do I represent it exactly? See guys, let me get some space over here. Let me find some space. In case of 3s, it's going to be like this. This is the nucleus. This is the electron density first of all, right? How many spherical nodes do I need to represent? 2 spherical nodes, right? This is the first spherical node. This is the electron density, right? This is the spherical node, right? There'll be one more spherical node after this. And this is the electron density, correct? So this is your 3s over here, in which you have got 2 spherical nodes. This one spherical node, this one more spherical node, right? Yes? Correct, people? Right. Yes, Balaji, I'll be taking it. Most probably. Perfect. I'm sure it's clear to everyone. This was all about your s orbitals. Now let's talk about your p orbitals, right? Let's talk about your p orbitals, people. Just a second. Let's talk about your p orbitals. In case of p orbitals, remember one thing. Psi versus r curve starts from the origin. Right? In case of your P, or you can say in case of your P, D and F. In case of your P, D and F, your psi versus r curves, they start from the origin, right? Yes? Now people see. Let's say I'm talking about 2P. First of all, what is the shape of P orbital? It's dumbbell shape, right? Now first of all, if I'll ask you how many total nodes will be there in case of 2P, n minus 1. N minus 1 means 2 minus 1. 2 minus 1 means 1. There is one node. Now is this node angular or it is radial? Check. What is the value of L for P? 1. That means this one node is angular. This one node is angular. This one node is angular, right? Okay. Now we will understand. In case of 2P, I need to plot a curve between psi r versus r, right? Will the curve start from the top? No, the curve starts from the origin. Yes. And in case of p orbitals, as you move far from the nucleus, the electron density increases till some point. Okay, then it decreases again. Okay. See guys, understand. In case of 2P, how many angular nodes are there? There is one angular node, right? The curve for psi versus r for 2P will be like this. It will be like this, correct? And how do we represent it exactly? See, this is the nucleus. This is one dumbbell. This is one more dumbbell, correct? This is one of the lobe which represents the electron density. This is one more lobe which represents the electron density. Now, where is the node? Where is the node? See guys, I've told you there is a plane cutting in the middle, right? At which the electron density will be 0. And that plane is basically what we call as the angular node. This plane is basically what we call as angular node, correct? This is something which we call as angular node. You call it as nodal plane or you call it as angular node over here. So there is one angular node in case of 2p. Yeah? Yes? Right? Similarly, if I talk about 3p, how many total nodes are there? There are 2 total nodes. Out of this 2, there is one angular and one radial, right? One angular and one spherical, one angular and one spherical, right? Okay, one angular and one spherical. So first of all, what is going to be your psi r versus r curve for it? Psi r versus r curve for it. You'll be starting from here, right? How many nodes there are in total? How many nodes are there in total? There are 2 nodes basically, right? There are 2 nodes basically. So see, the curve is going to be like this, right? Yes. Which node is this one, people? Which node is this one? Can you let me know which node is this one? This is the radial node. This is the radial node over here, right? If you need to make it exactly, you have to show 2 nodes. You have to show 2 nodes. One should be spherical, one should be angular, right? So it's going to be like this. See, this is the electron density, right? There will be one spherical node like this. After this, electron density will be again there, right? This is basically your 3p. This is basically your 3p, right? In case of 3p, this node is what I call a spherical node, and there is a plane in the middle at which electron density will be 0, and we call that plane as the angular node. This is the angular node. So there is one spherical node, one angular node, right? Yes, there is one spherical node, there is one spherical region at which the electron density is 0, and one at the middle, one plane at the middle, right, where the probability of finding the electron is 0, right? Yes, perfect. So there are basically 2 nodes. Yes, people, clear to everyone? Clear to everyone? Similarly, if you talk about 4p, how many nodes are there in total? There are 3 nodes. Out of them, 2 are spherical, and 1 is angular. Right? You can plot this one as well. You can make this one as well, right? You can make this one as well, I'm sure about it, right? So let me make it for you. This is first of all psi r versus r, correct? All the p, d, and f orbital psi versus r curves, they start from the origin, right? Okay, so this is your one radial node. This is the second radial node, right? Then it's going to be like this. And people, as you move far, these peaks keep on decreasing. These peaks keep on decreasing with time. These peaks keep on decreasing with time, right? Okay. See, this is your radial node, this is your radial node, correct? Now you need to show it exactly. You need to show it exactly. How you are going to show this 4p over here? See, I'm going to represent over here only, right? This was your 3p. This was your 3p. Let's convert this 3p into 4p, right? There will be one more region, one more spherical region where the probability of finding the electron will be 0. And after that, electron density will further start. Yes, this is the electron density. This is the electron density, right? So as you can see right here, this is your spherical node. This is one more spherical node. So 2 spherical nodes, right? And 1 angular node in the middle. 2 spherical nodes, 1 angular node in the middle. These are the 2 spherical nodes and 1 angular node in the middle, right? This is now your 4p. I'm sure it's clear to everyone, right? Yes? Right, people? Clear to everyone? Right? Now people, understand. If you want to plot a curve between psi square r versus r, the curves between psi square r versus r, they are going to be in the first quadrant only. They are going to be in the first quadrant only, right? What do we mean by that? See, for 1s, if you remember, I plotted a curve between psi versus r. For 1s, I plotted a curve between psi versus r, and the curve was like this, if you remember, right? Okay, this whole curve, is this curve going down the r-axis? It's not going down the r-axis, right? If it was going down the r-axis, I was supposed to erase that part, and for that part, I was supposed to take the reflection along r-axis, right? I'll be telling you in some time, right? See guys, this curve is remaining in the first quadrant only, right? It's not going down, it's not going down, it's not going down over here, right? So this curve is basically psi versus r curve, and at the same time, it's psi square r versus r curve as well, right? It is psi versus r curve, and at the same time, it's psi square versus r curve as well. Let me point it over here. This is psi square r versus r curve as well, Okay, point number 1. Point number 2, if you talk about 2s, what was the curve for 2s? Between psi r versus r. For 2s, it was like this. For 2s, it was like this, right? Okay. Now, I need to plot a curve between psi square r versus r for 2s. Psi square r versus r for 2s, right? How it's going to be, how it's going to look like. See, the first part I'm going to keep as the same. The first part I'm going to keep as same till here, right? Now this part which is going downwards, let's take its reflection along this r-axis, right? Okay, so this part I'm going to make it over here. I'm going to make it over here, like this, okay? So this is your basically the psi square versus r curve for 2s, right? Yes, so whatever portion was lying down the r-axis, I just took its reflection, that's it, yeah? Clear, people? Now similarly, let's try to plot few more curves. Say, if I've got 3s, for example, if I've got 3s, right? What is the psi versus r curve for 3s? See, this is psi r versus r, okay? What was the curve for 3s? It was like this, 1, 2, and like this, right? Now, which part is remaining downwards? This part is remaining downwards. Let me change the color so that you can visualize it properly. This part is remaining downwards, at which the psi is negative, right? At which the psi is negative. Now, people, if I need to plot a curve between psi square r versus r for what? For the same 3s. For the same 3s. See, till here, the curve is going to remain same. The curve is going to remain same. Now this part is going downwards in the negative side, right? Let's erase this part, take its reflection over here. So it's going to be like this, right? Yes, then this part was already there. This part was already there. And as you keep on moving ahead, the peaks will start going down. The peaks will start going down, right? This is basically your 3s. This is the curve for your psi square r versus r for 3s, right? Yes? I'm sure it's clear to everyone, right? Right, people? Yes, these curves are asked in your NEET. Yes, Priya, there is a session on VJE Enthuse mock test, right? Yes? Okay, one more thing. I'm sure you have made all these curves. Few more curves. For example, I'm starting with, 3p. I'm starting with 3p, right? What was the curve for 3p? What was psi versus r curve for 3p? Yes, it was starting from here, right? Then it was going down, then it was like this. Okay, this was psi versus r curve for 3p. Okay, now people, what is going to be psi square r versus r curve for 3p? This is psi square r versus r curve for 3p, correct? What you guys will be doing, see, this part is basically down the r-axis. Take its reflection, take it up, right? It's going to be like this. It's going to be like this, right? This is psi square versus r for the same 3p, correct? Yes? Right? Exactly. Now, let's talk about, for example, 4p, right? Let's talk about 4p. What is going to be psi r versus r curve for 4p? Say, there are basically 3 total nodes, right? So the curve is going to start from the origin. It's going to be 2, 3, and like this, right? This is the curve between psi versus r for 4p, correct? Now, if I want you guys to convert it into psi square r versus r curve for 4p, how it's going to look like? See, this part is going down the r-axis, take its reflection, that's it, yeah? This part you are going to write as such. Now take the reflection of this part along r-axis, so it's going to come like this, right? And then this part was already there, right? So it is basically your 4p. It's basically your 4p, correct? I'm sure it's clear to everyone, right? Yes, people? Now, if I'll be giving you the curves, from the curves you can determine the orbital as well. From the curves you can determine the orbital as well. How come? Have a look. For example, I'm giving you a question like this. Let's say I've got a curve between psi square r versus r, right? And the curve is like this. Okay, can you let me know which orbital this curve belongs to? Which curve this orbital belongs to? Can you let me know which orbital is it? See, first of all, the curve is starting from the top, right? So it must be S only. It must be S only, right? How many total nodes are there? 1, 2, and 3. Total nodes are 3. Total nodes 3. That means n minus 1 is 3. N minus 1 is 3. That means n value is 4. So it is valid for 4s, right? Yes, it's valid for 4s, absolutely. Yeah? Okay, one more curve I'm giving you. One more curve I'm giving you. This is psi r versus r, right? Psi r versus r, correct? And the curve I'm giving you like this. For example, like this. Can you let me know? Can you let me know which orbital it's going to be? Can you let me know which orbital it's going to be? See, first of all, again the curve is starting from the top. It's going to be S. How many nodes do we have? 1, 2, 3, and 4. There are 4 nodes. That means n minus 1 is 4. If n minus 1 is 4, that means n value is 5. So it is basically valid for 5s, right? Yes? Correct, people? Exactly. Exactly. Okay, can you let me know what about this curve? This is psi r versus r, right? The curve is like this. The curve is like this. It is valid for what? It's valid for what? Yes, UV, these curves are valid for NEET. Mickey, S orbital curves do not start from the origin, right? S origin curves do not start from the origin. It's absolutely going to be either P or D or F, right? So first of all, there is only one angular node, right? There is only one angular node. It's absolutely going to be 2P, right? It's absolutely going to be 2P, correct? Yes, I'm sure it's clear to everyone, right? Let me give you a few questions as the homework, and you are going to let me know their answers in the chat box. And with this, I'll be stopping the session here, right? I'm plotting a curve between psi square r versus r, and the curves are like this. Okay, this is one curve, psi square versus r. Let me know which orbital it corresponds to. Yeah. The second curve which I'm giving you, that's between psi r versus r, and the curve is like this. Okay, curve is like this, okay. The third one which I'm giving you, this is for example psi square r versus r, and the curve is like this. The curve is like this. These are the three questions which I've given you. I want the answers of these 3 questions in the comment section, right? People, I'm sure everything is clear till here. With this, your quantum mechanical model is done and dusted as well, right? Okay, and by the way, at 10:30, I'm taking one more session on Vedantu JEE English channel for that is basically the mock test. You guys can join in and have the mock test with me, right? And this is the PDF which you'll be getting at the end, right? This PDF you'll be getting at the end of the session in the Telegram group, right? In this, I have made all these curves, correct? Right? You will be getting this, you'll be getting entire data in the Telegram group, so do get enrolled in that as well, correct? I know I was sounding a little low today because my throat is not in a good condition, right? I know I was sounding low a bit because my throat is not in the good condition, yeah? All right, people, if you have not enrolled into the pro subscription, into the actual long-term batch yet, do get enrolled in it as soon as possible. The next batch is starting mostly on Monday, right? And if you want me to train you, take any one of these plans. You can take these plans for a month as well, right? Any of these 3 plans. These are 3 plans basically, right? This is the course fee for 2 years. This is the course fee for 2 years for this plan. And this is the course fee for 2 years for this plan as well, right? If you are new to Vedantu, you have no idea how the actual Vedantu classrooms are all about. You can take these plans for a month. You can see if it is working for you, and I'm sure it will definitely work for you. You will love it, right? Okay. The long-term batches are far more interesting than that of YouTube sessions. You can get the idea. Yes, you can take any one of these plans for a month, see if it is working for you. And if you'll be using this code WSPRO, you'll be directly enrolled into the My batch, right? Yes? Okay, and how to get enrolled in how to take these courses? See guys, this is the video which you guys are currently watching. This is the video which you guys are currently watching, right? You just need to drag this video a little down. Just drag it down, click on show more. After clicking on this show more, you need to click on, just a second. See, these are the chapters which we have taken till now. Structure of atom for class 11, that's done. This is the playlist link, right? You need to go a little down. From here, you can download the Vedantu free learning app, right? You can go a little more down as well. I don't know where is the link. Where is it? Just a second. Yeah, subscribe to Vedantu Pro now. You need to click on this link. After clicking on this link, you need to go a little down, right? Yes, you can take any one of the plan which you want, right? You can take it for a month as well. For example, I'm taking this light plan for a month. I need to click over here, try for a month, give my number, give the email on which you get the OTP and everything, and from here you get enrolled in the long-term batch as well. So people do get enrolled in it as soon as possible, because the next batch is about to start, right? Yes, the next batch is about to start, so do get enrolled in it as soon as possible. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Well, people, this was all from my side in the tonight's session, right? The next chapter which I'll be starting, I have no idea about it. You guys let me know in the comment section which chapter do you want the next, right? From next week, I'll try to give more sessions for class 11 people as well, right? I know you guys are lagging behind because of NEET 2021 examination, but once the NEET 2021 is done, right, since from then I'll be completing your whole syllabus in not more than 2.5 months, right? So I'm stopping with this. You guys take care. I'll see you guys tomorrow. Yes, Sanjay, hope to see you soon, right? Bye. Take care people. Good night. Bye-bye.